We are going to return to a study of parabolas in this section. If you are one of my Honors Algebra 2 students, we're actually in section 9.2 rather than 9.3. Now let's discuss what a parabola is. By definition, a parabola is the set of all points equidistant from a fixed line called the directrix and a fixed point called the focus. So what we're going to do is begin with putting those two parts on our graph. So anywhere on your graph, I'd like you to put a horizontal line. Okay, that's going to be the directrix. And somewhere above it, I'd like you to put a dot. Now what we're looking for are all of the points that are equidistant from a fixed line. So between this and this is going to be the vertex of your parabola. So put a dot there halfway between, because by definition it fits that. So we're going to draw a parabola. Take that. So by definition, what this says is if I pick any point on the parabola, and I use the distance formula to measure the distance between that point and the focus, and that point and the directrix, then the distances are the same. That defines a parabola. So what we're going to learn how to do is we're going to refresh graphing, but we're also going to learn how to find that focus and find the directrix, as well as the axis of symmetry. And if you remember that, the axis of symmetry is the vertical line that goes through the vertex. Not all parabolas face up or down. Some face left and right, and we're also going to learn how to do that. Okay, so we're going to put them all together so that you can compare. And we're going to begin with the equation that we're used to, which is y minus k equals x minus h squared. We've used this before. This is in vertex form. And if you remember, the vertex is going to be hk. Okay, now, how we find the focus. First of all, let's put a parabola on our graph. And just make one that faces up and leave yourself plenty of room because we need to label some things. And I want you to put a directrix on here. And an equal amount of space away, I want you to put a focus, and you need to give yourself plenty of space. So, if each point on the parabola is the same distance away from the focus as it is the directrix, the vertex is going to be the easiest one to find because it's like straight down the line. I'm going to mark my vertex here in purple. And we're talking about a distance, so we're going to label this distance. The distance between the vertex and the directrix is going to be labeled C. Okay, that's also C. Now C is found from your equation. And we're going to say that we are going to let C, the distance from the vertex to the directrix or the vertex to the focus, equal 1 over 4 times A. And that gives you the distance. Now, your focus, depending on how you're oriented, if you look at this, if you're moving from the vertex up to the focus, what you're changing is the y-coordinate by a value of C. And so technically what you're looking at is no change in H, but a change in your K. Now the way I do this is that I graph it first, I measure my change in distance, and then I add it to where it needs to be added. Your directrix is that horizontal line, which is Y. Again, you're starting with K right here, and you're going down, so you're subtracting C. And so you have K minus C. And then your axis of symmetry is perpendicular to the directrix, and that's where the H comes in, and part of that is a little bit of review right there. Now, I'm going to so I am going to do the version of the parabola that opens left and right, and I put my let c equals 4a in the way. So I'm going to make a little arrow. We're going to come down here. What happens is you're just going to switch the x minus h and the y minus k. And what it does is it flips it over. What changes here is your vertex does not change. So let's start with, let's put a parabola on, and I'm going to open it to the right side. And I'm going to put a directrix on here and a focus. C is the same exact thing as it was before. C is equal to 1 over 4a. You're going to measure the distance the same way. The change here is that you're changing your x-coordinate this time instead of your y-coordinate. So you're going to add the c to the h rather than to the k. So your focus is going to be h plus c with a k. Now if it opens the other direction and a happens to be negative, then c will be negative and everything will be flipped over. And your directrix here is going to be x equals k, h minus c. It's an h. And then axis of symmetry, y equals k. Now these are a lot easier to find if you graph them first and then figure out all of these values. Okay, so let's graph these. I don't want to put an axis on here yet until I see where I'm going to be. The a always needs to be multiplied to the square term. Now I'm going to give you a warning here. The book approaches this very differently than I do. I prefer this method, so if you decide to go to the book for your notes, you're going to be a little bit lost based on what I'm doing here right now. So the first thing I'm going to do is find my vertex, and I'm going to start with doing a t-chart. Remember, the vertex goes in the middle. There's nothing subtracted from x and y, so that's going to be a 0, 0. What you're going to want to do here, whatever variable is squared, like the y here, that's where you plug in. And I only want to plug in points that are going to give me multiples of 4. So I'm going to do -2 and 2 and -4 and 4, because it comes out with integers and we like integers. So when I plug in the 2, that gives me -1 and -1. And when I plug in the 4, it gives me -4 and -4. So what I'm looking at is a parabola that is going to face left. When you have a vertical opening facing left or right, it's going to face the direction of the axis that is that sign. So this is going to face the negative side. And you can see most of my numbers are negative, so I'm going to put my x-axis way up here and my y-axis right down the middle. And let's graph these. So I've got 0, 0, -1, -2, -1, +2, and then the 4s give just barely enough room right there. And then I can connect this. Okay, so don't put your focus and directrix on here quite yet, but the focus is always located in the cup. The directrix is always on the outside. So just to refresh, the distance from the vertex to the focus and the directrix, 1 over 4 times a. A is the coefficient right here, so -1/4. And we're simply going to plug it in. So C equals 1 over 4 times -1/4. And that gives me a -1. Okay, so that one actually turns out to be pretty easy. And since I know that distance, I can go ahead and put those dots on there. So I'm just going to move over one dot, one space this way, and then I'm going to do my line. it gives you less formulas to remember if you can actually remember where it's going to be located. So your focus is a point, and what's the coordinate? The coordinate is -1, 0. Your directrix is the line. You do need to list the variable, and that is x equals 1. And your axis of symmetry is perpendicular to your directrix, and it goes through the vertex. So I'm going to sketch that on there. And that actually is going to be y equals 0. Now in this problem, before you begin, what we have is this 2y is here. I want to have the 2 on the other side, so I'm going to multiply by a half and actually have y is equal to 1/2 x squared. Now this is an upward facing parabola. I know this because my a is positive, and I'm going to make my t-chart. My vertex is 0, 0, and I'm going to plug numbers in that 2 will divide into. So again, I'm going to use -2, +2, 4, and -4, and since my x is squared, I'm going to plug in 4x instead of y this time. So this gives me +2 and +2, and 8 and 8. And this is an upward-facing parabola, so I'm going to put my x-axis down here, and I'm going to put my y-axis right down the middle, and then I'm going to plot my points. So I've got 0, 0, 2, 2, and then 4, 8. So make sure I get that. 2, 4, 6, X. Okay. I need to go up 2 more spaces. There we go. Okay. Now then connect them and you get your parabola. Crooked, but it's there. Alright, so your vertex, 0, 0, we know that. And we are going to find what the distance is between our vertex and our focus. And remember, it's 1 over 4 times a, and that gives me 1/2. So I'm just going to move up half a spot, and I need to zoom in just a little bit so I can see what I'm doing. So my focus is going to be here. Remember, my parabola got drawn a little crooked. And I'm going to go down half a space. Okay, zoom back out. Alright, so just look at the coordinate, and that gives you your focus. So your focus is going to be 0, 1/2. Your directrix is going to be y equals -1/2. And your axis of symmetry is going to be x equals 0. Okay, so far we've been graphing things that are centered with a vertex at 0. This one is not. What you're going to notice is my x's and y's are all mixed up. And what I want to do is keep only the variables that have a square in it together. And here I have a y squared, so I want to keep that all together on one side. So what I'm going to do here is I'm going to add the 2x and subtract the 6. And I'm going to leave a little space. Because my form that I want is x minus 8 times y minus k squared. I have a completed square, so we're going to revisit completing the square. We're going to complete the square of the y because that's where the square variable is. So you're going to half the 4 and square it, so that's plus 4. What you do to one side, you have to do to the other. So then you have 2x minus 2 equals y minus 2 squared. But I need an a, So I've got a multiple of 2 on my left side, so I'm going to multiply everything by 1/2 to cancel that out. And that gives me x minus 2 equals 1/2 y minus 2 squared. Okay, so we're going to do the t-chart. This is how you handle problems with not having a vertex at the origin. So I'm going to pick points that will give me a nice multiple of 2 inside my parentheses, and we're going to fill in that t-chart. What you're going to notice is that I plugged in values for y, whichever variable is squared is what you want to plug in. And this one is actually going to open towards the right. And since there are no negative x's, I'm going to put my y-axis way over here, so my graph is going to fit. And go this way. So at 10, I have positive 6, 1, 2, 3, 4, 5, 6, and negative 2. And I have 4, 0, and my vertex is at 2, 2. And then I have 4, 4, and then everything is graphed here. So the focus is going to be in the cup right there. So we're going to need to find what C is. Now, we found C on the last slide. There's no need to re-find it. But 1 over 4 times 1/2 is 1/2. So we're going to just move over half a box inside the cup right there. So the purple dot, purple line. What is the coordinate of the focus? We moved over half a space, so we're at 2.5. And then the y-coordinate did not change. The directrix crosses the x-axis. We took off half, so 1.5. You can do 1.5. And then the axis is perpendicular, and it goes through the vertex. And that's how we do these problems. So, lastly for parabolas, maybe not lastly, but for this one, we are going to write the equation of the parabola. So with equation writing, to me, it is easier if you sketch it. So I'm going to sketch this, and I'm going to put on an x and y axis, and I'll show you why I want to sketch this. Okay, my vertex is at 3, -1, so right there. And my focus is at 3, 2. So here's my focus, here's my vertex. The focus is always in the cup of the parabola. So in here, that is an upward facing parabola, which means my x is squared. And so what I'm looking to get is an equation like this, y minus k equals a times x minus h squared. Well, first of all, I don't really need to use the formula for much. I don't have to. I can plug in my points and find what a is, but why not just count them? So there's 3 blocks right here. That's 3 spaces. So C is equal to 3. So if C is equal to 1 over 4a, and that's equal to 3, then that means 12a equals 1, so a is 1/12. No need to plug in and then solve for a. You can just use your focus and your vertex to do that, and then substitute 3, 2 in for hk, and 1/12 in for a, and you're finished. So these don't have to be very complicated. In fact, they don't have to be complicated at all. There you go, parabola written.